Hello everyone, my name is MD Hasibul Hassan. Today I am going to present our study on a comparative analysis of community level mobile source emission using big data analytics. First, I want to thank Metroplan Orlando for funding this study. Ozone is one of the 6 criteria air pollutant regulated under US EPA's National Ambient Air Quality Standard (NAQS), alongside PM2.5, PM10, sulfur dioxide, nitrogen dioxide, and lead. Unlike most of the criteria air pollutants or hazardous air pollutants, ozone is a secondary pollutant formed in the air by the reaction of nitrogen oxides and volatile organic compounds in the presence of sunlight. NOx and VOC are the precursors for ozone that are mostly primary air pollutants emitted from both natural and anthropogenic sources. For controlling ozone pollution in a region, NOx and VOC control policy is a necessity. NAQS ozone standard used to be 75 parts per billion, annual fourth highest daily maximum averaged over 3 years. But it was reduced to 70 parts per billion and in 2015 in a national scale. From the regulatory monitoring stations of Central Florida, it can be seen that ozone design value in this region is in the verge of violating the national standard. If standard violation happens in the future, an expensive control policy will be imposed from the federal government to the local government. It is suspected that NOx emission from vehicular sources and VOC emission mostly from the biogenic sources and adequate presence of sunlight are responsible for high ozone design values in this region. Here are the county total NOx and VOC emission contribution from major natural and man-made sources. So we have 4 counties in Central Florida: Lake, Orange, Osceola, and Seminole. Orange County is the home to Orlando. So this is one of the major urban counties in the United States. So we can see from here that NOx emission are predominantly coming from on-roadway vehicles, followed by non-road engines and power plant emission. For example, in Orange County, the on-road emission for NOx contributes to 55% in 2011 and 48% to 2017. In Seminole County, the on-road emission for NOx is 79% in 2011 and 75% in 2017. For VOC, the emission is mostly coming from biogenic sources, coming from trees. But in urban regions like Orange and Seminole, if we consider an anthropogenic emission sources, vehicular emission is still dominant anthropogenic emission source for VOC. So this study will going to compare the vehicular NOx and VOC emission from extremely detailed crowdsourced mobility data and sensor-based traffic information dataset. As traffic has spatiotemporal heterogeneity, to generate traffic-based emission inventory, it is important to gather detailed, accurate traffic information. So streetlight mobility data platform that provide traffic informations like vehicle mileage traveled or speed distribution over a region or over a roadway segment. So using crowdsourced smartphone GPS mobility data could be a data set that can be used to improve the mobile source inventory for a region. So we collected VMT and speed distribution data from over 11,000 Central Florida roadway sections from Streetlight, and we collected vehicle ownership data from local DMV and meteorological data from county-specific airports. For comparison between this crowdsourced data and conventional sensor-based traffic emission data, we collected traffic data from Highway Performance Monitoring System dataset. Finally, a motor vehicle emission simulator (MOOCS) was used for estimation of emission from roadway segment and estimation of emission from the entire county. Annual 2017 special link level emission for NOx and VOC are showing high emission for Orlando downtown I-4 and Florida Turnpike and the Central Florida's peripheral high traffic roadways. The high NOx emission, highest one is over 100 tons annual in 2017, and for VOC is around 13 tons annual in 2017. Temporal distribution of emission in Orlando is showing high emission for NOx and VOC are expected at daytime, especially during morning and evening working rush hours across the major highway sections. The street level roadways, the minor roadways, are not observed with high emission even in the daytimes and in the rush hours. But the nighttime emission is low across the entire roadway network in Orange County. Here is the annual emission comparison between streetlight based emission model and MOVE's default and HPMS based emission model. Figure A and figure D are the MOVE's default HPMS model for NOx and VOC. Figure B and figure E are streetlight based emission model for NOx and VOC. And figure C and figure F are the difference between HPMS based emission model and streetlight emission model. The difference are calculated with this formula here. This is a percent difference between the two models. So for comparison purpose, we kept the total emission same for the entire roadway network to make an equitable spatial comparison between the models. For MOVE's default HPMS based model, the peak emission across the highly trafficked roadway sections are not present, but for streetlight based spatial emission distribution, we can see that it is heterogeneous with high emission near the busy roadway sections for both NOx and VOC, like this interstate in Orange County, these turnpike roads in Osceola County, some roadways in Seminole, and the peripheral Central Florida highways. So from the difference map, we can see the MOVE's default emission is mostly overestimating across the minor streets, the red ones, but underestimating across the major streets, the green ones, for both NOx and VOC. For temporal diurnal emission estimation and comparison, we selected three distinct roadway sections in Central Florida. One is Orlando downtown I-4, second is the Florida Turnpike, and the last is the Michelle Hammock Road. Orlando downtown I-4 is one of the busiest roadway section in Central Florida with a distinct morning and evening peak visible, and we can see distinct morning and evening traffic peak and emission peak visible for both streetlight and MOVE's default model. The streetlight model result are in red, and MOVE's default NOx and VOC model result are in green. So for the left figure, the emission estimation is by taking only one link at the middle of the roadway, but the right figure is the emission estimation by taking the entire roadway section. Streetlight model overestimated emission for all the hours if we consider the entire roadway section, but it underestimated the emission for all the hours if we consider only one section at the middle of the roadway. Florida Turnpike section is a rural highway mostly used by heavy-duty vehicles and high-speed traffic, where a working rush hour high emission is not observed. Rather, we observe only one peak at the middle of the day. Here, streetlight data overestimating emission for all the hours if we consider one roadway segment or like the entire segment. There are some reasons for that. One could be that there are inadequate and incomplete rural conventional traffic sensor data that are present, so that it is not depicting the actual traffic condition in this particular roadway. Hence, it is not depict. It is actually underestimating the total emission for all the hours in the day. Michelle Hammock Road is a distinct urban road that is located near University of Central Florida, which is the traffic in this road is mostly impacted by the university traffic during the day. So we are expecting to see different peaks in over the course of the day. So for street light model, we can see that there are several emission peaks over the course of the day. But for MOVE's default HPMS based model, their factors are such that they consider this urban street as a typical urban road, which consists of only two emission peaks in the course of the day. One is in the morning time and one is in the evening time. In conclusion, NOx and VOC controls from vehicles are required for ozone control, and traffic emission estimation, if we use crowdsourced mobility data, it is more accurate than if you use from the conventional traffic data and the MOVE's default estimation model factors. And this in the major highway sections, if we use this crowdsourced mobility data, it will gonna depict the actual peak emission in this section because of high traffic and high congestion. And this methodology can be implemented in any part of the United States to improve their mobile source inventory. Thank you for listening to the presentation. If you have any question, feel free to email me here. And to know more about our research activities, please visit our website.